Good morning, everyone. My name is Kostantinos Tsanakas, and for the next few minutes, I will be presenting you our study, which is entitled Paleogeographic Evolution of Alikes Lagoon, Pydna, Northern Greece, during the Holocene, based on geomorphological and sedimentological data. Alikes Lagoon is a low-lying wetland of approximately 12 square kilometers located at Cape Atherida in Western Mykos Gulf in northern Greece. The surface sediments of the wetland consist of Holocene unconsolidated marshy deposits, while Holocene fluviotorrential deposits occupy the channels of the ephemeral streams that drain into the lagoon. The depth and the area of the lagoon depend on the seasonal variations of the water level, as well as on the manual control of seawater inputs. A 2-meter cell-sized dam was used together with topographic diagrams for the geomorphological mapping, which was performed applying traditional fieldwork techniques and DGPS survey. Moreover, 2 shallow boreholes were drilled at selected locations with maximum depths of 1.9 meters and 4.5 meters respectively. Wet sieving was performed on 64 samples, and the percentage distribution by weight of silt clay, sand, and gravel particles was estimated for each sample. All samples were processed for macro and micro paleontological analysis. The chronostratigraphy of the cores was established by AMS C14 dating of 2 shell samples collected from Alikes Dio core at depths of 265 centimeters and 440 centimeters. The morphology of the area north of Cape Atherida is dominated by coastal cliffs of 20 to 30 meters in height, while the southern part consists of a gently sloping coastal low-lying plain. A relatively wide field of vegetated semi-stabilized sand dunes has been developed around the lagoon, acting as a physical barrier along the coast that prevents inland penetration of the sea waves and allowing marsh formation landwards. 2 groups of beach ridges were recognized at the eastern part of the wetland, signifying recent propagation to the east. The sedimentary records of the cores is generally characterized by a fining upward sequence of sediments. This sequence is marking the transition from an open shallow marine environment to a protected lagoonal one of lower energy. Both the sedimentological and the faunal analysis allowed us to distinguish 4 biosedimentary units providing clear lithostratigraphic sequences. The first unit, Unit A, confirms the existence of a coastal shallow marine environment, while C14 dating yielded an age of 6,820 years before present for this sequence. Unit B is described as a lagoonal environment with medium to low energy sedimentation, as indicated by both the granulometric and faunal analysis. Unit C is identified at the middle part of Alikes Dio core and is described as a mesoaligned to oligoaligned paleoenvironment. Unit D, which is found at the lowermost part of the sedimentary sequence of Alikes 1 core, marks the establishment of a mesoaligned marsh. The silt clay dominated lagoonal Unit B was found to be disturbed by an intersecting 7 centimeters thick layer of coarse-grained unsorted sediments, marking a higher energy allochthonous imprint, probably of tsunamigenic origin. The clear and abrupt change in the depositional environment is also marked by the sharp contact at the base of this coarse clastic layer. The clearly marine fingerprint is further enhanced by the documented microfauna, which indicates a high-energy inundation event, probably of tsunamigenic origin. According to the radiocarbon date, a minimum age of 4,330 years before present can be constrained for this high-energy marine inundation event. A similar strong marine signal in the same region is also documented by Racheter et al. In 2010 at B29 core, located 1.6 kilometers south of Alikes 2 core. AMS C14 dating of both samples do not serve as reliable sea level index points and therefore cannot be used as a precise means to estimate the tectonic activity of the study area during the Holocene. In this figure, we juxtaposed the dated samples of this study to the sea level curves by Lambeck and Purcell 2005 and by Vouvalidis et al. 2005 for the Gulf of Thermaikos. The diagram indicates that when considering a vertical range of 1 meter, as proposed by Vaki et al. 2016 for Cerastoderma shells, no or negligible tectonic vertical displacement can be suggested for the study area, as it is located slightly above the sea level curve of Lambeck. Based on the radiocarbon datings, it is suggested that the establishment of the lagoon can be safely put around the 6th millennium before present. During that time, the sea invaded a lowland area and created an open, shallow marine environment, which at times was disturbed by freshwater inputs. The confinement of the lagoon and the transition from the basal, open, shallow marine environment to the lower energy lagoon can be attributed to the formation and evolution of two groups of beach ridges, one originating from the north and the second originating from the south. The high-energy layer of allochthonous origin intersecting the lagoonal sediments of Unit B is associated to high-energy marine inundation. The sedimentary characteristics of this layer are typical of tsunami backwash. It is thus concluded that the area has been impacted by a tsunami, which occurred not long before 4,330 years before present. The relative sea level, relative local sea level in the Thermaikos Gulf was never higher than the present sea level. The existence of a marine shell slightly above the relative sea level curve proposed by Lambeck implies a negligible, if not any, vertical tectonic displacement of the area around 4,330 years before present. The latter could probably be associated with a possible extension of the Anthemundas normal fault in the Thermaikos Gulf, or it could also be attributed to regional tectonic uplift due to the proximity of the study area to the active tectonic structure of the North Aegean Trough, going also hand in hand with a concurrent tsunami impact. Thank you very much for your attention.